Alright, hello everyone, welcome to this video. Okay, so in the previous video I showed you how to train a machine learning model for custom object detection. And in this video I'll be showing you how to build an Android app for custom object detection using TensorFlow 1. We used an SSD model to train this, as it's mentioned over here. The TFLite has support for only SSD models at the moment. So we'll be using the SSD model here as well. So in the previous video I had these 17 steps. So over here the first 17 steps are the same, and then the rest 4 steps after that are additional. So just let's quickly go over them. Okay, so first we'll install TensorFlow 1. Let's open the Colab notebook from over here. I've made a separate Colab notebook for this so that you don't get confused. Open this, click the save a copy in drive, connect. Once this is connected, go to runtime and change runtime type to GPU, save, and we're good to go. Okay, so let's begin. The first 17 steps are the same as in the previous video. First we'll install TensorFlow 1. Okay, so once that is installed, confirm TensorFlow version. Okay, we have 1.15 installed. Next, import dependencies. Third step, create custom TF1 training and data folders in your drive. Okay, so go to your drive, create a folder named custom TF1, and inside that create another folder named training and another folder named data. So data, another folder named training inside this folder. Okay, that's good. Now next step, create and upload your image and XML files. Okay, so as you can see I have my images over here that I want to train with mask and without mask. I have two classes. So the images are over here and their corresponding labels in XML format, the Pascal VOC XML format, are over here. As you can see, this has the name of the file, the xmin, ymin, xmax, ymax values, and the name of the class over here. These are the Pascal VOC format file that I mentioned earlier. Just create their zip files and upload them to this custom TF1 folder. Now for the next step, okay, to learn how to collect images dataset and label them, you can head over to this article. I have given the link to this in both my blog as well as in the Colab notebook. I have given a brief overview of it over here in this blog, but for a much more detailed explanation you can check out the other article for dataset labeling annotation for images and videos. That will be really helpful. Okay, for the next step, upload the generate TFRecord.py file. Again, you can find this file over here. Okay, we have the generate underscore TFRecord.py file and other custom files that I have used over here. You don't need any of these other files, as I'll explain later on. All you need is this generate TFRecord.py. Download this and upload it to this folder over here in custom TF1. Okay, that's done. Now next step, mount drive and link your folder. Okay, choose your account, click on allow, copy the code and paste it over here. Now okay, this link, as I mentioned in my previous videos, this link this command just creates a symbolic link so that this path is equal to /my drive. You don't have to write this every time. You can just write /my drive and it will be enough. So okay, as you can see, I've listed the contents in my drive and we have a custom TF1 folder over here. Okay, that's good. Now for the next step, to clone the TensorFlow models Git repository and install TensorFlow Object Detection API, just run this command. And this will clone this models Git repository in the current working directory, that is the content folder, this one, in the Google Colab VM. We already had the drive mounted. Now we have the models Git repository cloned over here, and then change the directory to models research, compile and install the TensorFlow Object Detection API. You can visit the official TensorFlow page for more information on this. I'm sure it will help you. I've given all the links at the bottom as well. Over here in documentation and references, these links are from the official TensorFlow site, so they will definitely help you. Okay, so after installing the TensorFlow Object Detection API from over here, okay, so this is how we install this, the Python package installation. Okay, and this is the folder that we will be needing, research and object detection. Okay, so just to make sure that everything was set up correctly, run this 8th step. Let us test the model builder. Okay, as you can see, there were no errors, so that means our installation was fine. Okay, let's move on to the next step. Navigate to my drive custom TF1 data folder and unzip the images.zip and annotations.zip files into the data folder. First we navigate to this location, that is inside G drive custom TF1, inside this data folder. Right now it's empty. We navigate inside it and then unzip the images.zip and annotations.zip files into it. Okay, so that's done. Now we have both these folders over here. The images folder contains all the images. I'm using 1370 images, as you can see over here, and the corresponding annotation files in this annotations folder. Now for the next step, what we have to do, we have to create test labels and train labels folder. We have to divide the annotations into test labels and train labels, where test labels has 20% of the annotation files, 20% of these labels, and train labels has 80%. So since I have 1370 total number of images, the 20% of that is 274, which is why I've mentioned it over here. You can change this according to your total number of images. Okay, so just run this step. Now this will move 20% of the images in this test labels folder, and the rest 80%, that is 1096 labels, into the train_labels folder. Okay, so now we have both these folders over here. Okay, that's fine. Okay, for the next step, create the CSV files and label map.pbtxt file. Again, make sure the current working directory is the same as this one, and then run this XML to CSV script. This creates test labels.csv and train labels.csv file, and also creates this labeled map.pbtxt file containing the names of all the classes. It uses the classes mentioned in the XML files, the annotation files that we have used. So okay, all the 3 steps have been done successfully. Let's see. the label map.pbtxt file. Okay, it has both these classes mentioned in it. It's starting from id number 1. Now again remember, id 0 is reserved for background, so it starts from id number 1. Okay, test labels.csv, train labels.csv. okay, well, these files are fine. Now for the next step, to create train.record and test.record files, this is the command that we'll be using. Okay, so first again make sure the current working directory is this. Let's run this, and now we'll run this command for train.record. Python generate _tfrecord.py, this file that we uploaded earlier on in our drive, and then your train_labels.csv file. Now since the current working directory is this one, we just have to write this. If you are at any other directory, just make sure to give the correct paths over here. Now the next one is label map.pbtxt file. Again, it is inside this. Just write label map.pbtxt. This is the part of the images folder over here. This is also inside the data folder. And finally the part to the output file that we'll be saving, train.record. Similarly for test.record, we'll be using the same command. Run this. Okay, this has successfully created the TF records for both these files, train.record and test.record. And just double check this to make sure everything was fine. Now as I mentioned earlier, the train.record had 80% labels, so I had 1370 images, so 80% of that was 1096, and the test.record had 20% images, these test labels, at 274 files, so that will be 274 for test.record. So everything seems fine over here. Now let's move on to the next step. Download a pre-trained model checkpoint. So again, in this we'll be using the SSD Mobile Net V2 Coco. So let's run this step. This will download this pre-trained model checkpoint. This is the latest checkpoint for this, 2018-329. As you can see, we have this over here. Okay, so we can move on to the next step. You can either download this pipeline config file from over here inside models, research, object detection, samples, configs. This is the one that we'll be using, ssd_mobile_net_v2_coco.config file. You can either download this, edit this using a notepad over here, and simply upload this to the custom TF1 data folder over here, or we can simply just edit it over here itself and then copy it. That's what we'll do. Again, number of classes for this is 2. I am using 2 classes. Change test.record, train.record, and label map path to the paths where you have created these files. These paths should be relative to your current working directory while training. Now what I'll do is I'll give them the complete path using the Colab VM. As you can see, inside the data folder we have the test.record. Copy the path over here, go at the bottom, the train input reader and the eval input reader. This is for test, so give the path over here to the test.record file. Do the same for train.record file. Change the path over here. For the label map.pbtxt file, copy path, paste it over here, paste this over here as well. Next, change fine tune checkpoint to the path where we downloaded the checkpoint from step 13. If you remember the previous step, we downloaded this checkpoint. So we need to give the path to this over here, fine tune checkpoint, with the model.ckpt model.checkpoint file. So just copy the path to this folder. We have the model.checkpoint file over here. Just copy the path to this and write this over here. That is it. We have given the path to the model.checkpoint file. Then next, after this, change fine tune checkpoint type with value classification or detection. I'll be doing this for object detection, so I have changed this to detection. Change batch size to any multiple of 8 depending upon the capability of your GPU. Now since we're in Colab, I have set this to 24. You can change this depending on the type of GPU you use. Okay, so the batch size over here is 24, and change the number of steps to whatever you want the detector to train it to. So this is already set to 200,000. So you can also change this later on by passing it in the command, but if you want to change it over here, you can just make changes and then click on save. Just make sure once you make any change, wait for this star sign to disappear. That's we'll know when it has been saved. Okay, now next step, you copy this file to the my drive custom TF1 data folder. Now we'll see we'll have our config file over here that we made changes to. Just recheck it just to make sure. Okay, now for the next step, step 15, load TensorBoard. Okay, this will not show any output right now because we have not started the training process. Once we start the training process, that will give you an output. Now for the next step, train the model, navigate to the object detection folder in Colab VM. We have to navigate to this folder, models research object detection over here, because we have the model underscore main.py file over here that we'll use to train. Now this is the command that we use. So just run this python model underscore main.py pipeline config path. This is the path to the config file that we edited and copied, and this is the path to the folder where we'll save our weights during the training process. If you remember, we created this in step number 3. The training folder, it's empty right now. Okay, just run this. Now this will start the training process for you. Okay, so as you can see, this logs the output every 100 steps, and this also saves this checkpoint in regular intervals. I'll show you when it does. Okay, just one thing. So for best results, you'd stop the training when the loss is less than 1 if possible. Otherwise, just train the model until the loss does not show any significant change for a while. Okay, I'll be back once this has finished saving a checkpoint over here. I'll pause this video and come back later. Okay, so now we are at step 2100. Now this has saved one checkpoint at step 1218. If we go over there, okay, you can see we have one checkpoint. And now another thing, now you can check the output using TensorBoard. Okay, so now when we are at step 2400, we'll wait until this loss is less than 1 or becomes constant. So I'll pause this video over here and then I'll be back once it's done. Okay, so one more thing, in case we get disconnected have shown how to restart your training from where we left off. So in case we get disconnected, because I lose the connection, we'll have to carry out all these steps again. Okay, so now we've lost our connection, but we have these checkpoints over here, the latest checkpoints. We can just begin training from here. We don't have to start from scratch. So okay, now it's connected. Run the first step. Okay, so now we've installed TensorFlow 1.15. Print a TensorFlow version. Okay, we have 1.15 installed. Import dependencies. We can skip steps 3, 4 and 5 as we've already done those. We have all these files over here in custom TF1. Now run the 6th step, mount, drive and link your folder. Again do the same. Choose your account, allow, copy the code and paste it over here, enter. Okay, and the next step, again run this. This will clone the models git repository inside this again in the content folder. You have to run this every time you get disconnected, as I'm cloning this in the Colab VM. This content folder is inside the Colab VM, so if you get disconnected you'll lose all these variables. Now again test the model builder. There should be no error. Yes, okay, everything was fine. Now next we can skip this step as we've already copied and unzipped this images.zip and annotation.zip. We already have these files over here. You can skip this step, you can skip this step too. We have already have done those. Skip this step, again skip this one, skip this too. You can skip all these steps until the step number 15. Just run this again. Now I've mentioned it over here. To restart training you have to run all the steps from the start again, but skip steps 9 to 14. So the last step we did was step 8 to test the model builder, and after that you can skip all these steps and just run step number 15, load TensorBoard. Now as you can see, this already has some output over here, as we have some checkpoints saved over here in the training folder. Okay, now we can restart the training process. This was for training. To restart, now all you have to do is just run this again. This will restart the training from where it left off, from the previous checkpoint. In case that doesn't happen, in case that doesn't work, all you have to do is go inside this config file and the path where we've given the checkpoint, model checkpoint. You have to write model checkpoint and then the number of the latest checkpoint, like so. Click on save and then you're good to go. But this is not required. This will automatically find the latest saved checkpoint and start training from there. As you can see, restoring parameters from checkpoint 2422. So it will automatically start training from the last saved checkpoint. So this is how you can continue training for as long as you'd like, because Colab will kick you off its VM, as there is a limit to stay connected to Colab VM. It allows a maximum duration of 12 hours. So you can come back and restart training using this process that I just mentioned. Okay, so now it's the loss is at 3.03. I'll come back once the loss is below 1, and then I'll show you the next steps after that. So I'll pause the video and come back later. Okay, so now we're at step 168258. As you can see, it has saved a checkpoint at step 168158 where the loss is less than 1. We can let this go on for a little while longer until the loss becomes constant, but I'll stop it here just for demonstration purpose. Okay, so now we're done with the training process. We have this checkpoint over here, and now we can move to the next step, test your train model. For that, we'll export. First we'll have to export our inference graph using this. Now if you go to models, research, object detection, as you can see we have the export inference graph py file over here. We'll use this file, input type image tensor, pipeline config path, the file or config file over here, the path to it. Next train checkpoint prefix, this will be the latest checkpoint number. Okay, as I mentioned earlier, we have over here our latest checkpoint 168158. I've written this over here. You can change this to whatever your latest checkpoint is. And then lastly, the output directory where we'll save the inference graph. Just leave it as it is. And now what this will do is save the frozen inference graph inside the data folder. Custom TF1. Okay, so make sure there are no errors. Writing pipeline config file to custom TF1. Okay, that was done. So go inside data, and inside that we'll see the inference graph folder over here. Okay, so we have all the files written over here. This is the frozen inference graph. It's around 18.35 megabytes. So just download this to save it. But we'll be needing it over here. Now the next step is to test our trained object detection model on images. Again, make sure the current working directory is this one. Okay, and the next step is optional. This is just for the font type, just to make the font type a little larger on the detection boxes. Okay, in the last step for this testing the object detection model running inference, you have to make a few changes. First, change the number of classes to your number of classes, and this is the path to the image directory that we have. I have saved 3 images over here. Now remember, the more the images in this directory, this will take a longer time, as this runs this inference for all these images present in this directory. Let's end with .jpg or .png format. So I only have 3, so this won't take very long. Now again, this is the path to the labels from over here. Just copy path and paste it over here. And this is the same path to checkpoint. This is the path to the inference graph folder. To this, copy path. And lastly, this is the frozen inference graph.pb file that we have inside it. This will just join both these paths. So just leave it as it is. I'm just explaining this to show you what this really does. Okay, so just run this to see if the output is okay. Okay, this is the minimum score threshold, the minimum accuracy required for object detection. Right now it's set to 10%. You can change this. Okay, so let's look at the output. As you can see, this has successfully detected all these masks in this image. For the next image without mask, okay, this is also fine. And for the next image also, this is without mask, this is with mask. So the train model is working nicely. Now let's move on to the next step for this. that is export SSD TFLite graph. We'll be using this again inside this object detection folder. There's an export TFLite SSD graph. This one is for TensorFlow 1, so we'll be using this one right now. Next is the pipeline config path. Okay, give the path to the config file. Again, train checkpoint prefix. Okay, this is the latest number of your model checkpoint. So our latest number is 168158. That is what we'll write over here. 168158. Next output directory TFLite. This will create a folder named TFLite, and make sure you add this post processing underscore op equals to true. Okay, so just check if there were no errors. Okay, converted 324 variables. Okay, so it looks fine. Go to the data folder. Yes, it has created this TFLite folder, and inside this we have both TFLite underscore graph.pb file and this pbtxt file. This is around 18 megabytes. So okay, that is good. Now let's convert this TFLite graph. This is a TFLite graph over here to the TFLite model. Okay, so first we can check the input and output tensor names using this command. Okay, as you can see, this is the input tensor name, normalized input image tensor, and the output tensor name is TFLite detection post process. You can also check it using a software called Netron, which I have on my system. Okay, you can open this using Netron. Okay, as you can see, we can see the input array name over here, normalized input image tensor, and you can go at the bottom and look at the output array name, TFLite detection post process. If you click on this, it has 4 values. The output types of each is float, and it has 4 values. So just one thing to note that is important: for object detection we use 4 values. So over here, as you can see in output arrays, we have given 4 values: TFLite detection post process, then post process 1, post process 2, and post process 3. This is required for object detection. For the image classification training, this is not required. You need only one output array. So I'll show you that in another video where I'll be training an image classification model. Right now, for object detection, this is what we require, as there are 4 values that are needed to represent detection result, number of detections, the score of the detected boxes, and the category of the detected boxes. So okay, now over here, as you can see, I have written 2 commands. First one is for float, the second one is for int. So we have to run these separately, or because I've mentioned the same output file name, if you run both of these together, the second one will just override the first one. So run this first one for the floating point. Once you get that value, you can download that and then uncomment this for int and comment this one and then get that value. So okay, let me explain what this does. We are using TFLite underscore convert. This is the simplest command we have in Colab for converting to TFLite model. Okay, then graph def file is where we'll give the path to the TFLite underscore graph.pb file over here, as you can see, this one. Then output file is where we'll create output final TFLite model. I'm naming it as detect.tflite model for object detection inside the TFLite folder, inside this folder itself. So, and the format for that will be, output format will be TFLite. Input shapes for object detection, this is the default value 1, 300, 303 for mobile net. Okay, so now the name of the input array is this one I mentioned earlier, and output arrays, we have 4 values for object detection. And then next, the inference type will be a float. Finally, allow custom ops. Click on run, and this will create the floating point TFLite model for this. Over here you can download this. Similarly, you can run it for int as well. Now for a quantized int format, we have to add a few other parameters like default ranges, minimum and maximum, mean values, standard deviation values, and change conquer input ranges, and the rest is all same. You can run that and get the quantized version TFLite model. For that, right now we have this floating point TFLite model. Okay, as you can see, this is around 17.65 megabytes. So now with the latest samples for machine learning in Android, we require metadata to be attached with our TFLite models. I've mentioned this over here as well in my article. You can read my article for much more detailed explanation of this entire process. It will help you understand this. Okay, so as you can see, the new TensorFlow Lite samples require that the final TFLite model should have metadata attached to it in order to run. You can read more on this over here on the TensorFlow site. Okay, so now I've given these 3 steps to just create metadata and attach it to the TFLite model. Just run them. Pip install TFLite support nightly. We need this for metadata. And then next, we create a directory like this, TFLite with metadata, inside this folder TFLite. So okay, we have this. Right now it's empty. And next, this is the process where we'll create the metadata for it. This is a very simple process. Just run this cell, you'll be fine. You have to make just 3 changes. The model path, you have to give the path to the TFLite model that we created. If you're following my steps as above, you won't have to make any changes. But if you have made changes like in the path or the names of these files, make sure all these paths and names point to your files. Label file, you have to point to a label map.txt file. Now this is not the label map.pbtxt file as we have been using till now. We don't need this one. For this we need these two, the names of these classes mentioned each in new line. We need the text file. Okay, we need this one. This is important, so make sure you don't make any mistake over here. Okay, so this is the label map.txt file with the names of each classes mentioned in each line. You can create this using Notepad. Okay, and upload this to this data folder. I already have done that. This is the label map.txt file. Okay, so we're good to go. And last, save to path. This will be the output directory. We created this in the previous step. I created this directory for TFLite with metadata. So we'll just save the final TFLite model over here inside this as detect.tflite. It is not in this folder, it will be inside this folder. So you can change these names just to be able to differentiate. Okay, so run this. Okay, as you can see, associated files populated label map.txt. It has populated this. Okay, fine, let's open this. We have this final TFLite model, and this one will have metadata attached to it. Now we can simply download this, and that is the last step according to this Colab notebook. Download the TFLite model and adjust the TFLite object detection sample app from TensorFlow's GitHub. Now you can for the next part of this process, what we have to do, now we finally have the TFLite model with metadata and our label map.txt file, the text file. Okay, Okay, for the last step, as you can see, what this requires is you to download the new detect.tflite model with metadata and put it inside the assets folder in the object detection Android app and run it in Android Studio. So we can download the TensorFlow Lite examples archive from here. Okay, as you can see, inside the Lite folder examples, we have all these. We'll cover all of them in other videos, but for now we just need this object detection sample app. Let's just download this entire folder. You will find an object detection folder inside. Okay, this is the folder that I was talking about. Now we have to copy the detect.tflite model with metadata and the label map.txt file inside the assets folder in the object detection Android app. Examples: object detection Android app source main assets. Okay, once we have downloaded this, extract it, paste this on desktop. Also detect.tflite. Okay, now inside this examples folder, light examples, we have object detection over here, right? Now what we can do is we can open Android Studio. Okay, in Android Studio, open an existing project, head over to examples master, light, inside that examples, object detection Android. Okay, this will open the object detection app for you. Now, okay, one thing that I have to mention, Google is working on incorporating TensorFlow Lite with Android Studio. So at the moment you can use only a select few TensorFlow Lite models. As you can see, this only supports image classification and style transfer models, provided they are enhanced with metadata. Over time, support will be expanded to other problem domains like object detection, image segmentation, etc. So until then, what we can do is follow these steps to install and run this custom object detection Android app. Okay, so if you go inside app, project, app, src, source main assets, this is where we'll have TFLite model and label map.txt file. This is the default label map.txt file. Okay, let's open this in Explorer, show in Explorer, and this is where, according to the next step over here, copy the detect.tflite model with metadata and the label map.txt file inside this folder. Okay, so all you have to do, just copy these two files. Okay, there is it. Now next, make changes in the code as mentioned on the TensorFlow GitHub link given below. This is the official GitHub for TensorFlow documentation. This is for TensorFlow 1, so it has mentioned all these changes that you have to make. Okay, if you head over to my article, I have mentioned those changes as well in a much more detailed way. So okay, firstly, edit the Gradle build module file. Open the build.gradle file. Okay, for the module, go back to Android, Gradle scripts. This is the build.gradle for module. The changes that we need to make over here is this: we have to comment out the apply from download underscore model.gradle. What this does is this downloads the default object detection TFLite model and overwrites our current custom TFLite model and label map.txt file. Just comment this. Okay. Secondly, if your model is named detect.tflite and your label files is named label map.txt, the example will use them automatically. You have to open this detector activity.java. This one, detector activity.java. As you can see, the input image size is 300, which we passed to create TFLite input array. Next, we have to make sure the API model file name is the same as ours, and also the label file name is the same. This is the minimum confidence. Again, this means 50% threshold, that is 50% minimum accuracy is required for your object to be detected. You can change this to whatever you want, 0.7f or 0.8f, whatever you like. And make sure that TF underscore OD API is quantized set to true if your model is quantized, and if your model is floating point, it should be set to false. As is mentioned over here, for quantized model these should be the values, and for floating point, let's confirm quantize since we have our floating point, so we'll set this to false. Once that is done, we can move on to the next step. Now this is the last step. Connect a mobile device and run the app. First, I'd like you to test your app on your testing device before making any more changes or improvements to this object detection Android app. Obviously, you can customize this app based on your requirements. You can make many changes, try to add Firebase functionalities to it so that you can save this in a database or something like that. But before doing any of this, just make sure it is running correctly. So I'll connect this to a mobile app and we'll see if it is working. Okay, first you can test it on a virtual device, AVD. This will give us an idea if it is working or not. Okay, so as you can see, the inference time is changing, so it means the app is working. Let's close this and test this on a real Android device to see if the object detection is working or not. I have this ASUS Android testing device. Let's run it on this. Okay, so as you can see, this is currently detecting my mask right now. Okay, let me remove the mask. Okay, it's showing without mask, with mask, without mask, and okay, that's it. Okay, so that's it for the app. Now if you head over to this article, I have given a note over here, and that says this object detection Android app demonstrates two implementation solutions, library task API and library interpreter. So you can read more about these on these two links. I've also given two more links over here. Okay, so you can read about both these implementations in much more detail. Now as I've written over here, if you're a beginner, you can just leave it as it is. The default that is selected is library task API, but I'll just show you how to change it. So let's go to Android Studio. Okay, so head over to Android Studio and select Android, build, click on select build variant. As you can see, we have these two: task API debug, task API release, and interpreter debug, interpreter release. You can change these implementations over here. So as I mentioned earlier, if you're a beginner, just leave it as it is. Okay, so I'm just showing you how it is done. Okay, so these are the library interpreter, library task API. Okay, and alright, one more thing that I have to mention before ending this video. These custom object detection apps like this that I've made, I have two classes, with mask and without mask, and I have trained it for a particular scenario, for a person wearing a face mask or not wearing it. So if we have another scenario, so it might give some false positives. So there are other methods to overcome those. This is just a basic tutorial on how to get started with custom object detection app. So for that we have ways like we can train the other objects in that scenario, and you can write some code to exclude those objects. Okay, so just make sure to go through this article step by step so that you don't miss anything. And okay, that's it for now. And if you've enjoyed this video, please click on the like button and make sure to subscribe to this channel. And alright, I'll see you in the next one.